With the introduction of new technology toolpaths for finishing, FeatureCAM 2013 R3 has a number of new stock model options for 2.5D milling. The first, detect material thicker than, means FeatureCAM will ignore rest material thinner than a specified threshold. This helps to avoid thin regions being rest machined where the benefit of a second cut is negligible. Toolpath fragmentation can also be controlled when rest roughing from a stock model by specifying a minimum gap length. This replaces gaps shorter than a specified distance with a toolpath segment. Now in this particular part we can see we've got some sharp corner regions inside this pocket section. Now I've got two pre-created operations, in this case side 1 and side 2, and if we play this as a 3D simulation we can see this particular operation in this pocket leaves radii in the corners. We've also specified an amount of allowance on the side of this part as well. If we go and have a look at the stock model that's been generated from these two operations, we can see the corner region, the amount of material that's left. We can also see the allowance that's been left on the sides as well. So what we want to do is we want to machine up to this sharp corner as best we can with a smaller tool. We're still going to leave a small fillet radius, but we want to do this as efficiently as possible. Now in this case we're using a 25mm tool to machine this component so far, and we're going to use a 5mm tool to remove the majority of the material thereafter. Now if we go ahead and look at the next operation, so again a side machining operation, only this time we're using the smaller 5mm tool, but this is using the traditional technology process. If we go ahead and play this, let's do the individual steps. So we work our way through to the roughing of this operation, and we can see here, because this toolpath isn't aware of the stock condition, you can see it's machined everywhere. So this is quite inefficient because all of that material has already been removed. So what we want to do is we want to tell the feature about the stock condition and then use the new stock model options to try and make this a much more efficient process. So I'm going to turn off the traditional technology toolpath and just look at this next operation. So here you can see in this feature we've got under the stock curve we specified we want to compute the stock boundary from the stock model. We're using the stock model that we created and we're referencing the last operation that was added to it. Under the strategy page you can see we're using NT spiral for the roughing, and we've also checked the option for NT toolpaths for the finishing. Once you select any of the NT options, when you go to your milling tab you'll notice that the stock model options becomes enabled. Now in this case we left these values at default. What we're going to do is look at how these will affect the toolpath as we change the strategy. So the first value we'll be looking at is detect material thicker than. So this is going to analyse the amount of material that's left on the component, taking into account the allowance, and then we can apply how much of the material we detect when we're doing our initial operation. We can also increase this region by using the expand area by value. Finally we have a minimum gap length, so this will join up any toolpath segments at a particular level if their minimum gap length is less than that specified value. Now in this first instance you can see we've got the default values. So I'm going to go ahead and calculate this through my simulation as a 3D. So we play through our first operations, then we get our initial roughing operation, and then we get the finish pass like so. So let's have a look at that as a centerline simulation. So clearing that material away up to this point, I'm just going to remove the rest of the simulation, step the toolpath in, and we can see in this case we are roughing out these corner areas. We'll work our way around the component. So if I'm using the Alt F3 key just to sort of go through these segments. But we can also see that our machining operation is also going around all of these outside faces as well. It will then repeat and work its way further and further down the component. So really all we want to do is we only want to really sort of rest machine into these corner regions here. We're not really too concerned with trying to rough out these side areas because the finish pass will clear all that material. If we look at this again at our 3D simulation, again just rotating the view around, machining into this region, you can see we get the pocket being machined in each of the corners. Then we can see the pass going around the outside, taking that depth. So to make this more efficient, we're going to utilize some of these new stop model options. So the next operation, which is the side rest machining, this time if we go into the roughing, into the milling area, into the stop model options. So in this case we've set a 0 gap length, we've got 0 expansion, but we've set a detect material thicker than to 1 mm. Now this is a common mistake, is to set the material or detect material thicker than value to whatever the status of the previous roughing or machining operations was. Now in this case, if we go to side 2 and go into our finishing operation, because this was the last operation for that stop model, we left a side lever allowance of 1 mm. So this is where typically the value might be extracted from, that we'd use a similar value for our detect material thicker than. Now the danger here is if this value is too large, we could be left with very little rest machining at all. Now these values are also the same in the finishing. So let's have a look at this. Again, I'm just going to do centerline simulation and play this simulation to each of the operations. So in this case the roughing looks a lot more efficient. That's machined those corners quite nicely. Now if I come in and do the finishing operations, you can see we've only finished those corner regions as well. So using a value of detect material thicker than too large, we'll end up not machining the areas that we want to machine. And we can verify this with a 3D simulation. If we play this through, you can see we're left with material around the outside of the component. So how do we force this finishing operation to work its way all the way around the component whilst maintaining the efficient machining on the roughing? Well, we could use, in this example, the next option. It's under the milling, stop model options. We can drop these values. So we've got 0 expansion, detect material thicker than set to 1, and in this case we've set a minimum gap length of 270 mm. So this value is just simply extracted from the size of the component that we want to simply join up the segments. This can be verified just by measuring from corner to corner. In this case 265 is that distance. So we're specifying we want to join those segments up. So let's play this one. Again, I'm going to do this as a centerline simulation. So whilst this has given us our finishing toolpath that goes all the way around the part, it's also joined up our roughing segments as well. So again, this is not the most efficient way to machine the part. So what we want to do is we want to use these stop model options to try and really control the output. And in this case, if we go to the roughing, into the milling tab, stop model options, this time I've dropped the minimum gap length down. I've put in a larger detect material thicker than value, but this is still smaller than the original allowance for that previous operation. I've also applied an expansion to actually increase that region that I'm trying to machine. If we now simulate this toolpath, again as a centre line, we get more efficient machining of the roughing areas, and then we get a continuous finish pass that works its way around the component. If we play this as a 3D simulation, so tool comes into position, rest machines more efficiently than the previous operations, works its way around the component to rest machine those corners, and then we come in and do the final finishing operation all the way around the part.